Thank you for attending the Monsoon Outlook. Everybody tends to get excited this time of year with the hopes and dreams that may come this summer, and we've had a couple of really wet and active summers the last few years, and so we'll go into what our best guidance is telling us for this upcoming summer. So Johnny Malloy to my right here is actually the new district meteorologist. He joined with us back in January, and so I actually wanted to have him co-present with me this year. You guys have listened to me do this for a decade, and I know that gets boring. But Johnny brings a wealth of knowledge with him, not only from the research community, he with Arizona State University, undergrad, master's, PhD, but Johnny also spent quite a bit of time with ADEQ. He has a wealth of knowledge when it comes to the desert Southwest and what we see during the monsoon season. So we're going to talk about some of the basics, do a little bit more than what we've done in previous years, and then we'll get to the outlook. So with that, I'm going to let Johnny take it away.
All right, excellent. Yes, Monsoon 2023. So here we go. A lot of anticipation, right? So the official start is in 2 days, Thursday, June 15th. So it's a good time to start talking about what the monsoon is and what we can expect, or at least what we think could be happening this summer. So what I first want to do, though, is show you this. This is really cool. This is looking at the lightning distribution, climatology, if you will, of the entire North American continent over the course of a year. This is actually really cool because as we go through time here, we can actually start seeing the Midwest outbreak, the severe weather that we typically see. And then as we get closer into summer here, you start focusing on Arizona and look at this. You see this surge of lightning activity. So it's so cool. Without knowing anything else in our region and just looking at lightning, you can tell there's something unique happening in our area of the world. And as we go through time, we go through October, November, December, all the holidays, we start losing that lightning signature as the atmosphere tends to stabilize in the wintertime. And then if we cycle back, we'll actually see that all the way again. Every year, this pattern repeats in the desert Southwest. So this lightning is associated with the monsoon. But what is the monsoon? We are unique in that we share this monsoon climate across the world. It's not just us. Probably the most famous is India, right? But we are part of this. And what's really happening here, if you notice the kind of commonality between all these locations, is it's low latitudes near the equator, but next to water. And the key here is that during the summer months, we have a good contrast between heating the land and water. And so what this does is creates low pressure over the land surfaces, and we draw in all of that moisture around those land bodies. So it's pretty cool that Arizona and the desert Southwest in general can be considered a monsoon climate. But we want to dig in a little bit deeper in that, and let's focus in on our area here. So this is a nice cross-section cut of Mexico, Gulf of California, Gulf of Mexico, and then Arizona. So this is looking at kind of a snapshot of the land versus the sea in our area. And one thing you want to focus on at first is, of course, the sun. This is what drives it. So in the summer, it gets hot, right? So we got low pressure of the land, and that's starting to fuel our moisture for the thunderstorms. But there's a little bit more to the story, okay? So when we have all these nice water bodies, these moisture sources next to us, there's a huge difference between the land and the sea. And one thing about water is there's actually about 4 times more capacity for it to hold heat. So the sun is constant over our head, but the land is behaving different than the water. And in this case, again, low pressure, high to low pressure, we're getting that moisture drawn into the surface, interacting with our topography, and we get thunderstorms. Pretty cool. But there's even more to the story than that to build up to this. This is really important for the conceptual model of the monsoon as we look into the outlook. Because what we're looking for are ways to actually interfere with this monsoon circulation. And we'll talk more about that, of how that's possible. But an important thing here is it's not just the low levels. We actually got to start looking aloft too. So when you have a lot of low pressure at the surface, you start having all this mass start to move up in the atmosphere, and that creates high pressure. So what's so cool about this is that on our planet, just because of the spin, we actually have the Coriolis effect. This actually influences our monsoon, because if we have a lot of high pressure aloft, and with the Coriolis effect, we actually get a clockwise spin. So what that means is we have to be very careful or be mindful of the different moisture sources around us. So that clockwise rotation aloft actually is very significant for the monsoon circulation itself. Here we go. So this is kind of a walkthrough of what we have with our monsoon. So this is a conceptual model. So at first we typically have westerly winds coming from the Pacific. We had a very wet spring and winter months, right? These are the storms coming from the Pacific with the jet stream. So, but as we fast forward to the summer, as we saw with that lightning, that difference that we saw, the change in the atmosphere, what's happening here is we're getting a more south-southeast flow. So we got the low pressure forming, we got the high pressure aloft, and together this actually creates a nice coupled monsoon circulation. This is what we want to see. So the high pressure comes up from the south, builds. We have our moisture sources. Because we got that clockwise flow, it starts tapping into that. We got the strong heaving of land. This actually creates even more of a drive from the high to low pressure. This starts converging on our topography, and voila, we actually have some awesome thunderstorms that we see in the summer that can even hit Phoenix at times when the conditions are right. So this is actually a really cool conceptual model. I love this graphic. I know it's cartoonish, but it really hammers the point home of what the monsoon actually is. This is what we're looking for every year. So that ridge, though, that high pressure is very, very important because this is essentially it's steering the fire hose. It really dictates where the moisture goes. So where that clockwise placement is on the land will actually start directing where that moisture is favorable to interact with the terrain to get our thunderstorms. So that ridge location is really, really key. And over the years, really it's the early 1990s, the research community really latched onto how that high shifts and what that means for us. And there are 4 main patterns that we're looking for on the daily with our weather outlooks. These are the ones we're looking for. These are the ones that have given us a flash flood threat, severe thunderstorms, just more thunderstorms in general. And a quick walkthrough here, type 1, that's what that means right there. And we're looking at the 4 corners high. This is a classic. So we get that ridge right over the 4 corners. That's why it's called that. Arizona, New Mexico, Utah, Colorado. And what this does, it brings in that moisture from the south and southeast. And this is where we get situations where Tucson starts getting it. We start getting it from the mountains from the east. We get our biggest dust storm threat under this pattern here because it's that southeast flow. Now moving to type 2 pattern, as the ridge can shift around, this is the Great Basin high. So this is actually an interesting pattern to bring us even more severe weather from the north. So when you're walking outside in the monsoon, you tend to see the thunderstorms build up on the horizon, right? Or in the valley, the mountains favor the thunderstorms. Well, under this pattern, you want to look north and east. So it's the Mogollon Rim, near Prescott area, Bradshaw Mountains. What's cool about this pattern, that clockwise flow, is actually going to start moving those thunderstorms off into the valley during the early afternoon and even evening. So this is a one that we want to look out for that rim to valley setup is what it's called. Type 3, this is a trapping high. This can create havoc on our forecasting. This is a situation where you have basically broad high pressure in the area that tends to sit and trap all of our moisture. It's very soupy, it's very humid air mass. We still have a lot of local forcing with our mountainous terrain. So things tend to just recycle. It just every day it repeats. And the pattern doesn't move very much at all. So that moisture, once it's there, it's entrenched. So that's one we definitely want to watch for as our group for when we do get these flooding events that are possible. That's something on our watch list. Type 4, this is actually the transition. You can actually see this one now, even on the calendar, or later in the season. So this is when the high starts to build up or retreat. So when it retreats, this is our fall and winter pattern where that jet stream starts coming in and starts deflecting the high, and our moisture is essentially swept away. Right now, what we want to see is this high actually move up and bring in that moisture. Though even throughout the season, this can still sit in this area here. So that's something that we want to watch for. The reason why this is significant for a flash flooding threat, I talk about being on the transitions, is that later in the season, we can have tropical activity. And so this is a good pattern to start steering that tropical activity up to us. So you remember 2014, that was the big famous event, right? So those are situations that we want to be mindful of towards the end of the monsoon, or even just if we have tropical activity and we see this setup. So it's worthwhile to actually go through those different patterns just to show you that it's not set in stone on the monsoon here. The key here, though, even with all that variability in the pattern, right, there's favorable patterns for more thunderstorm days than others, but does everyone get rain? Not really. No, this is actually typically what we see here. The typical thunderstorm or air mass thunderstorm, what we typically see in Arizona and the monsoon in general, are these single cell thunderstorms. They can be 5-10 miles across, and that's about it. So you get all the forcing that's necessary through a mountain, forms up, drops heavy rain, maybe 1 to 2 inches. Pretty significant, right? But not everyone gets it. And that's the key of the monsoon. The spatial coverage of the rain takes a while to fill in. So you see this mosaic pattern that starts to develop. If you look at our estimated rainfall through the season, you'll see the checkered mosaic pattern start filling in. And really at the end of the season, that's when you tally it up and see if you were above or below. That's kind of the idea there. Most of the times this is what you see in the monsoon season. So you may get wet, but your neighbor does not. All right, so monsoon significance. So even though not everyone sees rain, collectively over the season, it is significant from a hydrology standpoint, as it can be up to 40, 30%, even 50, 60% if you get closer towards the international border here for rainfall. So it truly is a summer rainy season for us. Even with all that uncertainty and smaller scale storms, it still adds up over time. And this is a classic climate graph that you'll see with a monsoon signature. So whether this be Phoenix or whether it be Mumbai in India, this is what you'll see. So what we're looking at here is temperature with the lines and then precip with the green bars. And you tend to see the monsoon signal hit right at this point. You get this surge in temperature, right? Heating the land, low pressure, bringing in that moisture, and then the rain kicks in like a light switch. This is what it's showing. So if you see this without knowing anything else, you're probably looking at a monsoon climate wherever you are in the world. All right, a little humor here. The North American monsoon, are you afraid of commitment? So the reason why I want to put this in here is because there is a lot of variability. One monsoon is not going to equal another. And it really keeps us on our toes for forecasting purposes and communicating what the monsoon can do. It's really, every season is like a snowflake. And I even put a note on there that it's very much like that. But there are some commonalities here. And one thing we want to track during any monsoon is dew point. So what this graphic is showing you here is the black line is average dew point, and the red is what was observed. So this is a very wet year last year, right? 2022 was very wet. And what you're looking at here is dew point through time from June 15th, September 30th. And dew point is the feel for thunderstorms. It's the lifeline of the monsoon. This is what we want to look for and track during the monsoon. The key threshold is around 50 degrees. It's measured in temperature. It's 50, 55 degrees or so. That's like kind of your marker where, hey, the atmosphere is ready to get some thunderstorms going, right? And so, but you can see here, through time, it's not always at that mark. So this is why we have what's called monsoon bursts and breaks. So bursts meaning rainfall, breaks meaning, all right, we're in a dry time. Everyone kind of just waited out for a bit. And you see that some of these break periods especially can be significant and long lasting. So in 2022, even though it was a very wet year, we still had parts of the year pretty dry. So you see that oscillation in the dew point. And again, this has to do with that ridge. Remember, it's like directing a fire hose. So as forecasters and meteorologists, we're always really interested in where that ridge sets up, because this can actually influence your dew points significantly, your feel for your thunderstorms. And it can be dramatic. It can be dramatic. If you get that ridge set up just right, all of a sudden your dew points go from the 40s up to the 60s, 70s, and that's right for thunderstorms. So I'll show a couple more years more quickly though this time, but just to give you a sense of what the variability is. So 2022, very wet. 2021, very wet. But you still see these bursts punctuated by breaks, right? And then it kind of has that very variable feel to it, right? Now, if we step into 2020, this was a very dry monsoon, very dry on recent memory. Even talking with some of our folks here, Steve, this is just a very dry, enormously dry monsoon for us. We just didn't get the right ingredients in place at the right time for us to get our thunderstorm chances, and it shows. Look at this. This is our feel. This is like trying to drive without gas. It's not going to work. So it's well below that 50, 55 threshold that we like to see, and drastically below there at times for a long duration. It just never quite got its act together. That monsoon circulation never got its act together, at least in a sustained way and over our area, and it shows. So it's kind of cool. Just like the lightning, you can look at one variable and kind of get an idea of what's going on. So lightning, feel for the thunderstorms being dew point. All right, so 2019, again, just showing the variability. 2018, and we got one more to go. And 2017. So the take-home message here is that every season is variable. So it'll be very interesting a year from now to look at what 2023 ended up being. And we'll talk about what that might be here in just a minute. So yeah, every monsoon is like a snowflake. So just to hammer the point home before we transition to actually looking at the outlook, this is what we saw over the past, since 1981. This is really the historical record of our alert network. So what you can see here is that just like dew point, it shows up in the rainfall record itself. This is looking at the average of our network. So yes, that one single thunderstorm that affects all of our networks. So it's averaging all the rain events, right? And you can see that there's an average around 3 inches. Pretty significant since our area averages around 7 to 8 inches a year anyway. So again, the monsoon is significant even though it's variable. But you see this oscillation with time, and it's very difficult to forecast. It's a very challenging part of the world to forecast for during the summer, and it shows. You got your average line 3 inches, but we've gone up to 7 inches recently, all the way down to 2020 being under, I think, a half an inch. So pretty significant contrast. So I think with that, let's go ahead and move over to the outlook of 2023. What can we expect?
Johnny got the fun part because he just gets to talk about all the background. Now I have to put my neck on the line talking about what we're seeing. You're all very, very familiar with 2022 and 2021. They were very active and very wet. And really it didn't matter what part of the valley you were in. A lot of places experienced quite a bit of heavy rainfall, flooding. 2020, you're all still very, that's sitting in the back of your heads too, again, how dry it was and how not active. So I'll say before I even get going, it'll probably fall somewhere in between these two. Record dry or record wet, right? Just kidding. Yes. Okay, let's start with where we've been. If you've been in the valley, or really anywhere in the state of Arizona, or even the desert Southwest this past winter, it was wet. It was a lot of snowpack, a lot of rain, a lot of multiple days worth of rain. Temperatures, it was very cool. In fact, it's still cool to this point in the spring. It's been wonderful, honestly, if you're expecting for that heat to come in June, and we're still doing all right. But really the big points to bring home here are the amount of rain that fell during the winter months. And that's kind of represented by the images on this to the far left right here, which is just showing that we're much above normal. And again, that's not only the desert Southwest, that's up into Nevada and California, of course, everyone heard of California, record snowpack. Again, temperatures are represented in that top left map right there. But let's do something that's a little more interesting that I found incredibly interesting, is in this image, this is a satellite image of our Goes West satellite, and what it's trying to emphasize is the amount of snowpack. So this was taken in late May, and I've done this kind of red outline across these states here, showing you more or less where the Rocky Mountains are, the Cascades, the Sierra Nevadas, and the areas that show up with green here are snowpack. This was the end of May, showing pretty much all the Central Rockies with snowpack, all of Sierra Nevadas with snowpack. There's some cloud cover in the Pacific Northwest, but quite a bit of snowpack extending all the way up into Canada for that late of May. You can't see it on here, but even the Sky Islands, Mogollon Rim, Flagstaff area still had snow, quite a bit of snow into late May. That's significant because not only has it been cooler than normal, we've had lots of precipitation, lots of snowpack. There's been quite a bit of research that's done in the past, what Johnny was kind of referencing to in the 90s, that show really wet winters, cool springs can wreak havoc on the positioning of that ridge that Johnny was talking about. Cool and wet winters and springs tend to slow down the northward progression of the monsoon ridge, which can delay the start to the monsoon or cause irregularities throughout the actual season. So this is significant. In fact, I can't remember the last time that I saw snow up on Mount Lemmon at the end of May, and I remember seeing it multiple times driving down to see parts of my family. So again, record snowpack. Okay, so what about June, right? It's been really nice in June. What you're looking at on the far left image here, I promise I won't hit you with too many of these technical graphs, but this is geopotential height at 500 millibars. More or less, we're taking a horizontal slice halfway up in the atmosphere, and geopotential height, the real key to take away from here is the higher the height, warmer temperatures are associated. Lower heights, cooler temperatures. So these yellows, oranges, areas of warmer air mass, the purples, blues, dark purples, colder. But what sticks out here, and this is a climatological for the month of June, so all Junes for the last 30 years, whether they're good or bad, for the whole month, and we can see right here, this is the monsoon ridge. It's central Mexico. It's trying to make its way north. Okay, that's the climatological average. Let's look at last year, what June looked like. And you can see those higher heights. So again, warmer temperatures, and that ridge is really far north from where it climatologically sits in June. It already got an early start, northward advancement. We know we had an active June, active July, active August, really wet monsoon. That's really what we want to see. However, I'm going to take a few snapshots of our current weather pattern, say again at 500 millibars,
And this is what we call an omega blocking pattern. This is actually from this morning. And so we actually have been having a persistent trough right to the west of the desert southwest off the Southern California coast. And really, the problem with this kind of blocking pattern is you see little movement. And when you have a trough sitting over a particular area, those troughs usually mean active weather, cooler temperatures. Again, represented, here's another way to look at the blues right there, show lower heights. And again, the lower heights, cooler temperatures, the reds, higher heights, higher temperatures. Up in Canada, all the forest fires going on, all the smoke you've heard about in the news, part of this kind of blocking pattern that we've had set up. But long story short, lower heights, cooler temperatures, desert southwest, this has been a fixture for all of June, and that's why it's been so nice outside. You can see the monsoon ridge being suppressed down here in the far central to southern Mexico. I mean, we'd love to see it here, but it's being stuck there. And I think in a way, this is almost, again, we're all, flood control dam folks here, right? It almost acts, this kind of pattern will actually suppress that ridge from moving north, therefore keeping us in a cooler pattern. We look at the forecast for the next 6 to 10 days, 8 to 14 days, we see below normal temperatures for the rest of June. Okay, it's still going to be hot. You still see temperatures in the hundreds, right? It's supposed to get really warm this weekend. However, 115s, 120s, I mean, probably not likely through the end of June. Again, but that's not a good sign for kickstarting the monsoon. All right, sea surface temperatures. There's two areas I want to take a look at here. We're going to talk about this one second. Everyone always cares about El Nino, Enzo, La Nina, what role that plays. But first, I'm going to focus on that other one, the Gulf of California there. And you can see on this map here, this is looking at sea surface temperature anomalies. So yellows, oranges, reds are warmer than average. Blues, colder than average. And you can actually see this really huge tongue of these colder than normal temperatures right here. And that's significant. I'm not going to get into the nuts and bolts of all the teleconnection patterns and whatnot, but for example, we have our Pacific meridional mode, and it's in a negative phase, which again highlights that cold tongue of sea surface temperatures. That's normally something that we see, and we end up having drier than average monsoons. Warmer temperatures, less precipitation. One of the mechanisms associated with that is looking at these sea surface temperatures in the Gulf of California. I talk about this every year. And the main reason for that is this is a great harbinger of when we actually see the onset or the storms to get going. The key number to find here is 27.5 degrees Celsius, and we want that temperature up in the far northern part of the Gulf. And if we look at sea surface temperatures right now, we're at that key spot in the southern Gulf, but we're still only about 22.5 degrees Celsius. Once we get to roughly around that 27.5 degrees Celsius, 90% of the typical rainfall we see in the desert southwest comes after that. We're still 5 degrees away. This time of year, we usually warm 1 to 2 degrees Celsius per week. But from that previous slide, temperatures are still running colder than normal. It could take another 5, 6 weeks before we see onset. We're in mid-June. It could be mid to late July before onset occurs. Is it a guarantee? No, but that's what the data is showing us. All right, Enzo. We officially went into El Nino advisory by the Climate Prediction Center just last week. What you're looking at here on the left image, again, sea surface temperature anomalies. Warmer than sea surface temperatures running from South America all the way along the equator out east. This is a classic ocean version of a developing El Nino. There's also an atmospheric piece to that, but long story short here is El Nino is here and developing. What you're looking on the right is we're moving out in time towards the winter, and then the percent chance of one of these occurring. Guess what the red bar is? El Nino. We're showing over an 80% chance into late spring, up to over a 90% chance while we get into the fall and the winter. So El Nino is expected to strengthen on this fall and the winter. What does that mean for the summer? Not really anything. In terms of strong El Nino, La Nina, and what kind of effects we tend to see in terms of like precipitation, what you're looking at is just a composite of all El Nino years. And I'm going to focus in right on Arizona here. You notice we're not seeing a lot of greens, which would mean wet El Nino summers. And we're not seeing a whole lot of browns, which means dry El Nino. You're actually seeing a lot of white, which means there is no signal. So it doesn't really have a key role in the summer. If you were to jump ahead to the fall, we're starting to see this bias towards the green. So more opportunities for wetter than normal. But we're not there yet. So what does it matter? El Nino, again, as we develop that El Nino pattern, that tends to enhance the East Pacific hurricane season. So we've actually been lucky for the last decade. It's been very active across the East Pacific. And as we all know, it only takes one of these tropical systems or just a little bit of moisture from that to get pulled up into the desert Southwest. Again, 2014, you know what we saw in September there. That was as a result to, again, a tropical system. But long story short, from the Hurricane Center, they're predicting above normal hurricane season. So something on the order of 14 to 20 named storms, 7 to 11 hurricanes, 4 to 8 major hurricanes active. And again, it only takes one of these or the moisture from one of them to potentially help and aid in, again, a really active burst period to the monsoon. And again, what we would need to see that is in late fall, or even this time of year, if that ridge is being suppressed in the West Texas area, you tend to get the perfect setup to be able to draw the moisture and or the system up into the desert Southwest. So it is a big wild card. It's boom or bust, because again, if you don't have a tropical system, this is dry for us. If you don't have that trough off the California coast and just the ridge, this is a dry pattern. And again, you just need everything to come together. So the possibility is there, but after all of my rambling, what are we predicting? What's the thought? So there's a pretty strong signal that's showing above normal temperatures. I know it's been really nice this the winter and the spring, but like a light switch, at some point we're going to transition into a much hotter pattern when the monsoon ridge finally makes its way north. So we're going to have to look forward to that, I guess. In terms of rainfall, all of the signals that we look at are predicting less activity, drier than normal. Again, this is averaged across 3 months though, both of these are. So this doesn't mean that we're not going to see thunderstorms. This doesn't mean that there won't be hot and cool periods. There will, we'll probably see a lot of it, but when you average it all together at the end of the season, odds do favor a drier than normal season with warmer than normal temperatures. So just to kind of tie this all with a bow here, above normal temperature, favored outcome, below normal rainfall. In terms of the onset, normally looking right around the 4th of July, odds favor a later start than normal. Maybe we go into mid-late July. We may actually get a false start. False start being it looks like we're going to start having that monsoon influx of moisture sometime into late June, early July, and it starts up for a day, and then the ridge moves out of its favorite position, and we dry back out. It's all kind of a hallmark for what we might see in this kind of season. Again, all of the favors, whether it's dynamical models, historical records, are all kind of saying irregular placement of the monsoon ridge suppressed, less number of days where we have the potential for rainfall. So again, that still points to this below normal for rain. And again, maybe we'll get lucky, and if we have a really active hurricane season, maybe later as we get into the fall, maybe we'll get an intrusion of moisture from one of those systems and have a really big event like, was it Rosa, Steve, in 2016 that it came on September 29th, 30th, and October 1st, and more or less gave us an entire monsoon's worth of rainfall in 2 days, right at the very end. So something like that's definitely possible. So we always want to remind you, again, it only takes 1 or 2 heavy rainfall events to reach the monsoon quota for rainfall. Your house in Scottsdale might get 3 inches of rain, but the airport might get a ½ inch, and that means it's a dry monsoon, at least when we look at the record. But for you, it might have been great, because you might be one of the lucky folks that gets storms on those limited days that we have. And of course, any location in the Phoenix corridor can see flooding rain. It only takes about a ½ inch in 30 minutes to cause flooding problems. We see it every year. So our last plug here is we have all this information and more if you go to maricopa.gov/monsoon. Get you ready to go before, during, and after the monsoon. So go check it out if you want to learn more information. And of course, if you're not getting our weather outlook, where Johnny and I are talking about all of this and geeking out every day during the monsoon, or actually all year, you can certainly head on to the webpage, click on the weather outlook banner, click on the subscribe for the Outlook, and it'll get sent right to your email. It'll look like this. And with that, you can always get a hold of us in the alert room. Someone's always there. If you want to ping all of us, floodinfo@maricopa.gov will come to our entire branch's emails. All right, thank you guys.